Hey everyone, welcome back. I am absolutely thrilled to have you here for another explainer. Today we're taking a magnifying glass to something you probably do, I don't know, dozens of times a day without even a second thought. Counting. But here's the secret. The seemingly simple act of counting is actually this fascinating, invisible cognitive matrix. It's a really complex series of mental leaps that we all had to master at some point in our early development. So we're going to look at the exact foundation of number sense to see how the human brain actually learns to quantify the world around it.
So let me ask you this. When you see a young kid pointing at a group of blocks and saying, 1, 2, 3, what is actually happening in their head? Is counting just memorization? A lot of us kind of assume that kids learning to count are merely reciting a memorized song, right? Much like singing the ABCs. But true counting, actual number sense, is infinitely more complex than just repeating a sequence of words. It requires building a solid bridge between invisible concepts and physical reality. To understand how we build that bridge, we're going to use a specific foundational educational standard as our blueprint for today's explainer. This is kindergarten standard NC.K.CC.4, and the overarching goal is simple but really profound. Understand the relationship between numbers and quantities. That single sentence is literally the absolute bedrock of all mathematics. It's all about how we connect the totally abstract idea of a number to the physical quantity of the objects sitting right in front of us. Okay, let's dive into this. Here is our structured roadmap for decoding this matrix. We'll hit the illusion of counting, one-to-one correspondence, the rule of cardinality, perceptual subitizing, and finally, the foundation of numbers. Section 1, the illusion of counting. We start by discovering the hidden complexity, where a child might just mimic adults, saying 5 numbers while touching only 3 objects, before the brain truly locks into gear. That brings us to Section 2, one-to-one correspondence. Let's slow down and look at the first real gear of counting. According to our foundational standard, establishing one-to-one correspondence requires 3 very distinct steps. Step 1, you have to say the number names in the standard order. You absolutely must know the sequence. Step 2, you've got to pair each physical object with one and only one number name. And step 3, which is a really crucial flip, you must pair each number name with one and only one object. Just think about the heavy cognitive weight of that for a second. It's a strict two-way street. You literally cannot skip an object and you cannot reuse a number word, which is exactly why a toddler counting the family dog twice throws the whole system into total chaos. Linking one specific abstract word to one specific physical object is a massive evolutionary leap in logic. Moving to Section 3, the rule of cardinality. This is the core realization, the ultimate aha moment in early brain development. Our source defines cardinality as recognizing that the last number named tells the number of objects counted, regardless of their arrangement. And this brilliantly illustrates the exact moment the brain finally masters quantity. Think about it. When counting 1, 2, 3, 4, the word 4 is no longer just the 4th step in a sequence. It suddenly transforms into a representation of the entire total. Furthermore, the standard explicitly notes, regardless of their arrangement. So whether those 4 blocks are stacked up in a neat little tower or just scattered wildly across the floor, the total quantity remains exactly the same. The physical spacing doesn't change the mathematical truth at all. Section 4, perceptual subitizing. This acts as a cognitive shortcut, almost like a sudden, fascinating superpower. Perceptual subitizing is defined as stating the number of objects in a group without actually counting the objects. It's a totally mind-bending ability when you really pause to consider it. The brain just instantly knows a quantity. It doesn't need to do that meticulous one-to-one pairing we just talked about. It doesn't need to recite the standard order of numbers. It just looks, processes the visual data in a fraction of a second, and boom, immediately recognizes the total value. It's exactly how you instantly know someone ate 3 of your fries without actually having to sit there and point at them and count. Now, what's really interesting here is the specific limitation placed on this superpower. According to the foundational standard we're decoding, this instant visual recognition tops out at exactly 5 objects. For groups of up to 5, we can perceptually subitize. We just intuitively know it's 3, or we just know it's 4. But once you throw 6, 7, or 8 objects into a scattered pile, well, that instant visual shortcut completely breaks down, and the brain typically forces us to revert right back to active, one-to-one counting, just to be absolutely sure of the total. Let's compare these 2 core concepts side by side to really solidify how our brains process quantity. On the one hand, we have cardinality. This is a very active process. It requires counting, it requires understanding that physical arrangement doesn't matter, and it relies entirely on the rule that the last number named is the total. On the other hand, we have perceptual subitizing. This is a passive, instant process. Absolutely no counting is required. It's just immediate visual recognition. But its weakness is that it's strictly limited to groups of up to 5 objects. So our brain essentially utilizes both an active counting rule and an instant visual shortcut to navigate the world.
Section 5, the foundation of numbers. Let's zoom back out and tie this whole shebang together.
We return to our main blueprint. Understand the relationship between numbers and quantities. So the crucial takeaway is this. Understanding isn't just a single light bulb turning on. Mastering these specific, sequential skills is what actually fulfills this fundamental standard of human cognitive development. You connect the word to the item. You realize the final word is the total. And finally, your brain learns to optimize the entire process by instantly recognizing small groups, which leaves us with this final kind of paradoxical thought. We spend intense cognitive energy mastering one-to-one correspondence just so we can count accurately, right? But the very moment we can, our brains rely on perceptual subitizing to skip counting altogether whenever possible. It really makes you wonder how much of our advanced mathematical logic actually relies on what we just intuitively see without thinking. I'll leave you to ponder the complexities of your own brain on that one. Thanks for joining me on this explainer, and keep learning.